Welcome students. In this session, let us look at the introductory concepts of deep convolutional neural network. First of all, you must know what is the need for CNN. Whenever a new technology or whenever a deep neural network is introduced, it is our duty to analyze the background on what scenario did this CNN come into existence. So if you closely observe, CNN is the not first framed deep learning neural network. Even before that, we had methods such as deep feed forward neural network. In short, we call it as DFNN. But there is a drawback of DFNN. What is that? The study of a number recognition. Say, for example, you have DFNN in your computer and it is designed to recognize the character or alphabet 8. When you give an input image, as we are seeing here, it says 100% and 8 if it is an 8. When you give an input as 5, it says 100% not an 8. So it is very clear, it's very comfortable. Now after 10 minutes, you are giving another set to the same algorithm. Again, you are giving same 8 and same 5. Now what happens? The answer changes. You can see when they are giving 8, it says no idea. That means it is unable to recognize 8. When you are giving 5, it says it's not an 5. So what happens here? What is the difference between the first set and the second set? The first set, the region of interest is in the middle, but in the second set, the region of interest is somewhere in the corner. It clearly indicates that DFNN works well only when the data is in the center of the image, which is not practically possible all the time. If you take selfies or if you take any other examples, most of the time the data can be available in all the portions of the image, need not be in the center alone. So in that case, how can I trust this DFNN for practical applications? I cannot. What is the solution for that? One option is you can have your input data at different locations and with different sizes. You can solve the problem to some extent. But however, already your deep learning model is having many layers. The complexity is very high. In that case, if you again increase the number of images for no specific reason, again, the system is going to hang or it is not going to process. Now, the third option you can suggest me is, no, we have supercomputers, we have higher-end processors. That processor can do everything quickly in a relatively lesser time. That may look fine, but the simple question is it really necessary to say that just by the position is changed, can we call it as a different method or can we call it with a different name? Absolutely not. So we are looking for some other solution which are much more practically feasible to detect the region of interest even if they are present in the different parts of the image. So the answer for that is convolution. So what is convolution? As per Wikipedia, it is a mathematical operation on two functions. So you need two functions to execute this convolution operation. One is the original image. Say, for example, let us assume F be the original image or the data. What is G? I will come to that at a later stage. Now, when these two are mixed together, we are going to have a third function which is viewed as a modified version of the original function. What is this modified function? It is a position translated version of your original function. So now it is very clear, instead of human representing the data with different positions and image, it can be automatically done by the algorithm itself with the help of convolution. Let us see how it is done practically. Let us take a simple image. You can assume this boy is sitting on a duck. He is not at the center of the image. So in that case, the system is not able to do the recognition. So how can we do that? We can use the convolution. So when you use convolution, what it is going to do is it is going to split the original image into many small parts. So when you have many small parts, the size is not increased. Put together, it is going to be of the same size, but the chances of the body part of the child being available in different pixels will increase. Look at this image. Now the original data is divided into 77 small tiles or images or frames. You can see that the body part of the child is available in many positions. Take the first row, you can see it is in the sixth frame, seventh frame, eighth frame. On the corner, in the middle, at the upper, at the lower end, in all possible directions you can find. Now, what is the conclusion? This convolution operation helps the system to recognize the data in a much more better way because it is available or the region of interest is available in more than one position in the input data. Now, when you look at the overall convolutional network, you can say three modules. The first module is convolution, the second module is max pooling, the third module is fully connected network. Among these three, in my opinion, convolution plays a major role because this is going to extract the important features necessary for finding the answer or recognizing the object in the original image. If at all the algorithm or the computer needs to say a boy is in the middle of the garden, it must be fed or supplied with the boy's data at different position, which the convolution is able to do. Now, before going into the detailed content, one question normally the students ask is how many layers should I have? Because in ANN, in another other LSTM models, we find that plenty of hidden layers are used. The same case is applicable here too. There is till now there is no concrete evidence that you should go for two convolution layers or five layers or two max pooling layers or one convolution, one max pooling and vice versa. There is no concrete evidence. So people try to make use of these methods in a trial and error method and then they try to freeze in on the best model for any type.